All right, we're going to go ahead and get started. I don't think it'll take the whole time, but we'll see. The examples that we have are long examples. There's only 2 of them, I think, and then we'll be done. So we're getting to 5.2, and then we'll stop. So simulation is the imitation of chance behavior based on a model that accurately reflects a situation is called a simulation. You already have some experience with simulation. Guys, can y'all start coming in like a minute or 2 early so that when it's 2:15 I can get done? Stop being interrupted, please. In chapter 1's hiring discrimination, it just won't fly activity, you drew slips of paper to imitate a random lottery to choose which pilots would become captains. The 1 in 6 wins game that opened this chapter had you roll dice several times to simulate buying 20-ounce sodas and looking under the cap. These simulations involve different chance devices, paper, cards, or dice, but the same basic strategy was followed in all 3 simulations. We can summarize this strategy, good gracious, using our familiar 4-step process: state, plan, do, and conclude. So here's how you do a simulation with state, plan, do, conclude. And that's what we're doing today, so that's why I said it's going to be a little bit longer. So ask a question of interest. About some chance process. To plan, you're going to describe how to use a chance device, to imitate 1 repetition, of the process, and make sure you tell what you will record. And we'll get to this in a minute. We'll do an example where you're doing all of this. It's not, sounds like it's crazy, but you've done most of it just at separate times. For the do, you're going to perform many repetitions. Why do we do that? What do you mean? Yeah, to decrease variability. So we want to rule out anything that could be confounding. So we want it all to be left to chance. Conclude, use the results to answer the question. So the question that we stated in the very beginning. You can look at page 296 for a table that shows each step in examples we have already completed. You don't have to look at that, but it's there for you to check out. So far we have used physical devices, for our simulation, using random numbers from table D or technology is another option, as the following examples illustrate. So we're going to get into one of those examples where we have to state, plan, do, conclude. And again, most of it you've already done. So we just got to put it in this format. Okay. Everybody good? You got it? All right. At a local high school, 95 students have permission to park on campus. Each month, the student council holds a golden ticket parking lottery at the school assembly. The 2 lucky winners are given reserved parking spots next to the school's main entrance. Last month, the winning tickets were drawn by a student council member from the AP Stats class. When both golden tickets went to members of that same class, some people thought that the lottery had been rigged. There are 28 students in the AP Stats class, all of whom are eligible to park on campus. Design and carry out a simulation to decide whether it's plausible that the lottery was carried out fairly. So we have to do this for them to see if it's fair. So state, what are we trying to do?
Decide if the thing is there.
Okay, so what was fair? We have to be very specific.
Golden ticket lottery.
What, why was it deemed unfair?
Because the kids who weren't
We're in the same class. So here's your question. You need to make sure you form a question based on that. What's the probability? That a fair, lottery ticket would result in 2 winners from the AP Stats class. So the plan part said, describe how to use a chance device to imitate one repetition of the process and tell what you will record. So what do we do? And it said we wanted to use table D, simulations with table D. So what can we do? How would you do it? So since we're using, I'm gonna go ahead and write up there. We're gonna use table D to simulate. Choosing the golden ticket winners. Mary Kate said, label them. How am I going to label them? How many? Yeah, 28 because we're talking about the calc students, the stat students. Okay. So we're going to label the AP Stat students 0 to 28, but what about the other ones? Because we have 2 groups, right? We have a total of 95, so we got to make sure we got all of them in that lottery. Right now, we just have the 28 in there. What do I do for the other ones? We have
label them 29 through 95.
Tell me why we had to do 01. Because there's 2 digits. So table D, you have to do that. If you're using your calculator, do you have to do that? No. Okay. All right. Now what do we do? Choose any row. What do we do? Reading left to right. What are we going to look for? What kind of numbers? Keep even more. Look for 2-digit number pairs. Why am I looking for pairs? Because there's two what? I'm looking for a pair of 2-digit numbers. Why? Two lottery tickets. There's two winners. Okay, so we're going to pull two students at a time. So we're actually looking at a set of 4 numbers, if that makes sense. Okay, so we're pulling 2 students at a time. Non-repeating. And what else? Within the range. What are those students? So the 2 that we pick are what? What will these students get? You can just put that they will win the lottery or that they will win. And then what are we trying to record?
If it's possible for the 2 students to come from the same class.
What are we looking for? What's our question? You're not wrong. We're going to be a little bit more specific. What's our question?
To see if 2 AP students in stats class can both get the tickets or whatever, the parking spots.
What's our question though? What's the very beginning of our question? What's the probability? So we got to find a probability. So we're going to repeat this a bunch of times. And then we're going to say, like, we're going to do it 20. I'm going to go ahead and tell you, we're going to do it 20. We're going to figure out how many of those 20 times there were 2 AP Stat students that won. Does that make sense? So what are we trying to record? We will record winners from AP Stats. All right, so then we're going to do it. Make sure that you perform repetitions. And I'm going to go ahead and tell you right now, we're going to use table D. You choose whatever line you want to when you're doing your problem, like if it's on the test or whatever, they'll probably tell you specifically which one to do. But I'm going to tell you right now, we're going to use table D at line 139. I need somebody to look that up. Table D at line 139. Even if you're a Zoomer and you have it, that would be amazing. What are my first 2 2-digit numbers? $55 and $58. So that's my first repetition. Okay, that's my first time. I told you we're going to do 20. What's that? Are these AP Stat students? No. So I put little X's. I'm going to put a big fat 0. None of them are AP Stat students. What are my next 2 numbers? 89, 94. What's my third set of numbers? 04 and 70. My next set of numbers are 70 and 84. My fifth set, watch this real fast. We have 10 and 98, but 98 is not in our range. So we ignore 98 and we move on to 43, which is in our range, okay? Is everybody good with that? All right, so that's how you deal with a number that's not within the range. So then our sixth is 56 and 35. Our seventh is 69 and 34. Our eighth is 48 and 39. And our ninth is 45 and 17. While y'all are getting those wrote down, we're going to go through them really quick. On the second simulation, on the second one, are either one of those AP Stats students? Remember, AP Stats are 1 and 28, 1 to 28. Yes or no? Are they AP Stats students?
No.
No. So there's 0 on this one. How about in number 3? Are there any AP Stats students?
04.
04 is 1, 70 is not, so that means one student won. One student for the AP Stats. The next one, 70 and 84. Neither are AP Stats students. In 5, 10 is an AP Stats student, but 43 is not. 56 is not, and 35 is not, so no AP Stats winners. None in the 7th. None in the 8th. But 1 in the 9th. Is everybody okay? All right, I'm gonna try to squeeze these in there so you guys can see them.
So when you said when we're using table D, we're like looking at these consecutively.
Yep. The table D should look
Like-
like this: 5, 5, 5, 8, 8, 9,
Okay.
4, 0, 4. Yep.
Okay.
And then you just keep going. And when you run out of line 139, you go down to 140. Is everybody good with that? So then your 10th one is 19 and 12. What do you know about those two?
They're both in the
They're
stats.
both AP Stats. So that's one of ours. So is it possible that they could win? Yeah, it's possible. 11th is 97, which will not work. 51 and 32. Neither of those are stats students. Our 12th one is 58 and 13. One of those is a stats student. 13 has 04 and 84. One is good, one is not. 14, 51 and 44. Again, I'm just going through that line. I just have it wrote down. 15 is 72 and 32. Neither are stats. 16 is 18 and 19. What do you know about both of those? So we got,
Both stats.
yeah, so we got 2. 17 is 40, 00. 00 is not in our thing, and 36. Neither of those are stats. 18 is 00, 24, and 28. Both of those are in stats. 19, 96 is not within that range. 76 and 73 are, but neither one are stat students. And then our last simulation of the day, 59 and 64, and neither one of those are stats. All right, so tell me what happened. Okay, don't be quiet now. Tell me what happened.
Still getting it all written down, Miss
Okay, I'll
Jones.
wait, I'll wait, I'll wait. No, you're fine. I'll wait. If you guys don't have your calculators, you're probably gonna need them for the next one, so. Or at least pay attention to how to do it. Rachel, you good?
Yep.
Okay, everybody else okay? What happened? What do we see?
That we can have,
Say it again.
that we can have two winners
Uh-huh.
from the
Tell me more specifically.
3 times out of 20.
Yep.
Go for AP stats.
In our simulation of 20 trials, both winners from AP Stats happened 3 times. So the question is, what's the probability that a fair lottery ticket would result in 2 winners from the AP Stats class? We would say 3 out of 20, but the actual question asks you to design and carry out a simulation to decide whether it's plausible. Is it plausible? Could it happen?
Yes.
Yes, it is plausible. Make sure that you answer the question they ask. That winners are from that class. That's it. Is everybody good? All right, flip it over when you're ready. And then on the next one, we're going to use technology instead of using table D. Is everybody good? Zoomers, I'm flipping it. Yell at me if you're not. I'll put it back. All right. In an attempt to increase sales, a breakfast cereal company decides to offer a NASCAR promotion. Each box of cereal will contain a collectible card featuring one of these NASCAR drivers: Jeff Gordon, Dale Earnhardt Jr., Tony Stewart, Danica Patrick, or Jimmy Johnson. The company says that each of the 5 cards is equally likely to appear in any box of cereal. A NASCAR fan decides to keep buying boxes of the cereal until she has all 5 drivers' cards. She is surprised when it takes her 23 boxes to get the full set of cards. Should she be surprised? Design and carry out a simulation to help answer the question. All right, so state. What's our question? How do we start the other one? What is the probability that what? What are we trying to prove? What is she surprised about?
She's trying to see how many times it can take her to get all 5 of the cards.
But she was surprised when it took her what?
23 times.
23 boxes. So what's the probability that it takes 23 or more boxes of cereal to collect all 5 cards? Good. These will get easier. The states will get easier. We're going to plan. So we have to plan to do it with technology. So a random number generator. What's the first thing that we always have to do? Mhm. We're going to label each card. And if we're doing a random number generator, we have to assign a number to each card. You have to show that. So on your test, a lot of you that did not print it, here's what happened. You may have gotten the correct like person or whatever. You guys know on your test where you had to do the random number, not random number, but the table D or whatever. Some of you labeled them like going down the columns. Some of you labeled them going across. But if I don't see how you label them, I can't justify it's the right answer. Does that make sense? So you have to show me those labels. So those of you that did it on separate paper, if you had those labels and they were right, then I could have counted it right. But if you don't give it to me, I don't. Most of you got it. You were fine. Okay. So don't stress about it too much. I just want you to know that you have to show the labels. Okay. So on this one, we label each card. What are we labeling them? How? Who? Who is one? And you can just do this. One is JG. Two is Dale Earnhardt Jr. Three is Tony Stewart. If we run out of time, just come back in. Four is Danica Patrick. Five is Jimmy Johnson. How do we use our calculator?
The random integer function.
To choose numbers 1 through 5. Representing the cards. When do we stop?
We've gotten all 5 cards.
Keep hitting enter. Until we have all 5 cards. So you're going to count the number of times you have to enter before you get 1, 2, 3, 4, 5. All right. So then we're going to do it. We're going to do it. All right. Remember that random number thing is under math and probability. Let me clear this out. All right. Random integer. Guys, if you look down here, they have one that's no repeats. Remember when we're trying to choose some without repeats, you could do that and that'll help you. But in this case, we want to have them in there, okay? So don't choose the one without repeats. So our lower is going to be 1, our upper is 5, and we're just picking 1 each time. So we got 1, that took 1 time. There's 3, 2, 5, so that's only 4 draws. 5, 6, 7. So it took us 7 times to get all 4, right? Okay. So we had, going back up, for our first one, 1, 3, 2, 5, 1, 5, 4. It took us 7 times.
So like on a test, if we had to do this, would everyone get different answers because the calculator gives you something new
Yes.
every time?
Yes, that's why they don't ever do it.
Okay.
That's why they always use table D and they specify exactly where in the table to do it. That's why I said y'all should have had the same 5 names on your test when you did the table D or whatever, but some of you labeled them differently. So as long as you got the same numbers, you were fine, but they also wanted the names. So like when we do this, if they say, what were your answers? You would have to say like Jeff Gordon, you would have to say Dale Earnhardt Jr. You can't just give a number. Does that make sense? So on your test, you got counted off for that. You got to give the actual names. All right, so if we do this again, we're going to hit enter. We got 2, 5, 4, 2, 2, 5, 5, 1. I'm just looking for 3 now. 4, 5, 4, 2, 1. This is the longest I've ever had to do this. 2, 1, 2, 5. Where is the 3? There it is. So how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 times. Then I'm just going to go ahead and tell you they did 50 trials. We're not going to do that much. I would say 20 would be the minimum right now. We'll talk about how many is good and how many is not later on. After 50 trials, none were 23 or higher. None of them. So what can we conclude? I would never ask you to do this for 50 trials. Okay, I would never do that. So what can you say? Guys, what can we conclude? Come on.
That the probability is highly unlikely and usually not
Not just highly unlikely, but
possible.
not possible. So in our trials, it never took 23 or more boxes to get 5 cards. So the probability is, yep. Should she be concerned? That's the question. Should she be surprised?
Yes.
She should be surprised. It took 23 boxes to get all 5 cards. All right, get that right down. I'm gonna leave out and come back in. Like I said, it shouldn't, we just have 2 more pages. These just take forever. The next one's just fill in the blank, and then the last one is check your understanding. It'll take no time at all. So probably maybe 5 to 10 minutes more. All right, so I'm gonna stop share, stop recording.